Greetings! In the next fairly numerous set of tutorials, I will go over creating database-driven applications, specifically the usage of DataMapper design pattern in conjunction with IdentityMap design pattern and Zend Framework. It will be a long series, not only because database-driven development is fairly long and complicated, but I want to go into proper programming practices, not just how it's done in Zend Framework. So I will have to extend the length by talking about just how to set up the classes in general. And I will also go into unit tests, which will further extend the length of the series. Zend Framework comes with two main database abstraction utilities, the table gateway and a row gateway. I don't like using either of those two because it restricts me to the table gateway design pattern. That pattern is not flexible as it allows me to access the database only through the tables and through the framework's definitions of those tables. And I don't have much room to access the database specific functions or go beyond tables into stored procedures or some other ways that are database specific, such as Postgres object relational tables. I will choose a middle ground by using the ZendDB adapter and ZendDB SQL directly. So I will be accessing the database specific features through construction of the queries manually, but still through the abstraction layers of the database adapter. So I take advantage of the convenience method for filters and security. Now let's see what is this I have in the background all this time. Here I have a file and class structure of a typical DataMapper design pattern layout. Anything that is related to the data is called the domain entity. These are the posts and the categories to which the posts belong. In order to get the posts and the categories, they have to be somehow queried from the database. That is done at the bottom layer through the DataMapper interfaces. At the moment we will be using the MySQL DataMapper, but in case we want to go and query it from the memory cache or even from the cloud such as Amazon's AWS services, all the data mappers share a common interface so that they can be swapped interchangeably depending on where the data is coming from. The data queried from the database then has to travel through the identity map. This ensures that the data is efficiently cached and the data storage is not accessed unnecessarily. This is the slowest component in your application. I had a client which didn't take care to store the results intermediately, and if there was a feature that reused some of the data that was previously queried, it still went to the database, and as such, for loading a home page, the database was hit over 20,000 times, causing a minute-and-a-half load. That wasn't very acceptable, so I implemented a structure similar to this, and with only accessing the database when necessarily, otherwise caching the results in memory, the load went down to a couple of seconds and the CPU usage went from 95% down to 1%. So this is very important. Once the identity map figures out whether the data should be reused from the cached storage or from the permanent database storage, it gives the result back to whatever has requested the domain entity, which in turn implements the domain entity interface so that it can be used as a parameter restriction dependency. To illustrate the concept a little easier, I will switch over to a sequence diagram style. Here we see how the call is processed in time. We have the post controller requesting from the identity map a post based on the ID or some other parameter like category ID, or maybe we want all posts all at once. Identity mapper in the background, without the post controller knowing, checks if the post has been cached somehow if it was queried before. If it hasn't, it asks the data mapper about it, again unknowingly to the controller, and get the object back. It adds that object to its internal cache so that the next time that post could possibly be queried for again, it doesn't have to repeat the call. And finally, it gives the final object back to the post controller. Now, I know I've used a lot of fancy language here. Don't worry too much if you're overwhelmed. Once we start writing our code, it will really become clear and beautiful. Okay, let's begin writing a code that reflects this wonderful diagram. And I have already taken the liberty to rename the tutorial into blog off the screen so that the naming convention is more natural. Now, according to the diagram that I have designed, I have at a minimum 2 components that make a successful blog: a post and a category to which the post belongs. They are related but quite separate entities still. There is going to be a post class that has the posts information, and there is the category class that has categories information. I don't want to jumble the 2 concepts together, so they will be separated. As such, I'm going to keep them together under the blog namespace, but I will subdivide them into child namespaces for post and categories. And by the Zend Framework's convention, I also have a namespace for the models. So the overall blog module namespace that houses the child model namespace that has my specific business logic namespaces. I will construct a file system to reflect the PHP's namespace. So it is somewhat of a challenge to keep track of these 2 separate concepts, the file layout and the PHP namespace layout. It takes some practice. Hopefully I'm not going to lose you. So I already have the namespace prepared for models. And now we'll create a directory that houses files for the post namespace and for the category namespace. Each one of those have the post class, the identity map, the data mapper specific to the database that we will be using at the moment. It's just asking me that now, huh? Interesting. And the DataMapper interface specific to this namespace. This is important because if we have multiple types of data mappers, one for, say, Amazon, the other one for Active Directory, the other one for MySQL, or whatever else have you, the identity map should not get lost as to which functions are available, which ones are not. All data mappers will be enforced to have these functions, the fetch post by ID and fetch post by category ID. Unless those methods are implemented in the data mapper, the application will throw an error. This way, the identity map is ensured to be always functional. There will never be an issue of inability to do something like fetch post by category just because it switched to a different type of data mapper. Following that, we need to create an exception, because I will be using exceptions to generate error messages so that if there is any issues, the user will be properly informed about what happened, so they can contact the developers and say, what does this error mean? Can you please fix it? And possibly, I haven't decided yet, do logging so the developer can know what has happened during application usage, why something went wrong. factory method will be later on, much later on, designed to facilitate the actual creation of the domain entities. For now, I will keep them inside of the DataMapper, the creation, but generally the construction of an object is a complex process and I do not want to mix the queries with the object creation. So what will eventually happen is once the DataMapper returns the raw data from the database, it will be passed to the factory that creates the actual domain entity object. So that takes care of this side. Now I want to do the same thing for the category, and it mirrors the files fairly well. Yes, of course, most certainly. And now I need to create in the models namespace files that will house common functionalities to both the child namespaces. So there will be some very common features of some of these classes, such as fetching of the ID of the entity object. That is something that we want to ensure is kept consistent across all namespaces. So I will take the getID method outside of the individual namespaces into the overall model namespace. That way I'm ensuring that getID is being consistently done properly, that agrees with the convention for the rest of the application. I will later on move these out of the way. I can do that now, I suppose. Those are my old ones. So domain entity interface, yes. Now see, if I was working in Java, I could actually have this program called Visual Paradigm for UML generate a complete Java code for me. But PHP just doesn't have the enterprise tools the way Java does, and it is fairly disappointing. And finally, let's do DataMapper abstract. Okay, so I'm pretty much done here with the diagram, so now I can permanently switch to my text editor. Okay, and we can start filling that out. I will start by defining the domain entity interface. It will serve dual purpose. First one is to define the type so that any entity map by the model can be seen as a domain entity. And second, it will house the parent namespace directory, if you will, for the blog models. That is done with namespace blog, because we are under the blogs namespace as defined by the module. And to define a type that we want the domain entities to be. Following that, let's do domain entity abstract. Same drill, belongs to namespace models, calling it domain model abstract, and it has a property that I want all the child classes to be able to get to, and that's its ID, something to uniquely identify it. I want all child classes to be able to get ID nice and easy without having to duplicate this code like that. I'm not going to put status as part of the main model abstract because I want to return a unique instance of self every time I set a variable. You'll see the use of that when we get there. After this, I want to do a domain mapper abstract. Which has a property for the database connection. This property will be set on the object creation stage, so we want this to be a constructor. The constructor will take the type, and here we finally see some Zend in action. Zend db adapter, and it's complaining that it can't find it because I need to import it with use. Let's see, what do I want? I want Zend db adapter. So I want that, which will take adapter. Now we can take care of some of the post namespace specific classes. We can start with a DataMapper interface for the post namespace. Namespace models, blog models post. And as our diagram has suggested to us, we must absolutely have fetch post by ID and fetch posts by category. And category is also being controlled by ID. Okay. And I should just, before I forget, go back and make sure that my IDE knows about what type of variables these are, so my code completion can work properly. One there and one here. This will give me... No, it's not a mixed variable by any means. It is a post, which I haven't defined yet. I'll do that in a little while. The actual data mapper and once again, before I make a fool of myself, I need to remember that this is an abstract class, not just any class here. And okay, just little details. This is an actual class. Extending the main mapper abstract and implements the DataMapper interface. We're having an error because we don't have all the methods that are required by the DataMapper interface. I'll just leave that for now. Yeah, I should really call this an ID here. There we go. And the error went away. I'm later debating on whether I should make this parameter as a category object so that it then on the fly decides what's the appropriate way to find it by the ID or name. But we'll get there when we get there. And move on to post for now. Here it now is complaining it cannot find models. I will resolve it with a use statement. There we go. So the post class is under the post namespace, which is underneath models. But to be able to see the classes under the models, I have to let it know about what's available up one level. It's a bit confusing, but you have to be very explicit in terms of where you're picking up the classes from, and PHP cannot automatically figure out about the existence of the parent namespaces. It can only look at the immediate name. So just have to get used to this notation. This post will have a title, which is of type string. It will have a setter method that is setting this title. And by my convention, which once again we will see the use of much later, I will return an instance of self. This is why I didn't want to put setters of any kind up in the abstract class. I will want to do the same thing for the ID. Well, actually, before that, I want to get a title. Nothing there, which gets returned this title. Gives me a string. This one gives me not so much this as post. Yes, that post. And what else I need? The ID that I left out. The ID is in a protected place. It's coming from the domain entity abstract. Post and ID. And there we go. And I'm being very careful with my doc types. For two reasons. One is the code completion in the IDE. When I will actually begin using these models, it will be incredibly helpful. And secondly, this will become useful when I do unit testing. Just a little bit more to go with identity maps. This time I shall not forget the abstract keyword. Not going to worry about interfaces at this moment. Should be enough for now. I'll refactor if necessary later. And this needs to have a protected data mapper that will be attached to it. Okay, I'm not going to create an abstract constructor for this, because the data mapper is going to be unique to the namespace it's at. So implementing a concrete one now. And let's see, what is it that we needed to have? We needed a constructor, and let's just do at the minimum get post by ID. It will take a DataMapper interface of the post namespace, not some other namespace, but post specifically. And I'll just call it DM, and it will set the DataMapper from there. Return an instance of self, just in case. Not so much useful in the utility classes. And now the private methods that are very important to the identity map. Private function is post cached ID. It's going to return a boolean at some point. And this method here will be calling the data mapper attached to it. It will return a post model. Having set up the file structure, we can create some basic unit tests that will verify that when we get to the Zend database abstraction layer, we will have the data as expected.